This video covers Section 2.4, Part 2, Review. From point on level ground 80 feet from the base of a building, the angle of elevation is 25.6 degrees. So we're standing out here 80 feet from the building, and the angle of elevation is 25.6 degrees. So that refers to this angle where you see the top of the building. The angle of elevation is 25.6 degrees. Approximate the height of this building. So in that triangle with that angle 25.6 degrees, we have the opposite and the adjacent sides. We have the adjacent side given. We want to know the opposite. So that's a tangent function. Tangent of 25.6 degrees equals the opposite over the adjacent. So you multiply both sides by 80 feet, and we get 80 times the tangent of 25.6 degrees. So you need a calculator to figure that one out. So you pull out a scientific calculator, and we do 80 times tangent 25.6. And it gives us, to the nearest foot, 38.3. That would be to the nearest tenth. And then to the nearest foot would be 38 feet. Number 38, two buildings with flat roofs are 60 yards apart. The height of the shorter building is 40 yards. So if this height is 40 yards, the buildings are 60 yards away. The taller building looks something like this. So this distance between them is 60. And so from the shorter building, from its roof, the angle of elevation to the edge of the roof is 40 degrees. Find the height of the taller building to the nearest yard. So the triangle that we're looking at has this 40-degree angle, and we know this is 60 yards. We're going to get this little extra height here, and then we already know this is 40. And so if this is x, then the height of the taller building equals x plus 40. And so the 40-degree angle, the x is opposite and 60 is adjacent, so we use a tangent function for that. Tangent 40 is x over 60. So that little extra height above the 40-foot building, 40-yard building, is 60 tangent 40. 60 tangent 40 rounded to the nearest yard is about 50. It's the height of the building is x plus 40. $90 yards. Next one, you want to measure the height of an antenna on the top of a 125-foot building. There's the antenna on the top of a 125-foot building. From a point in front of the building, you measure the angle of elevation to the top of the building to be 68 degrees. And the angle of elevation to the top of the antenna to be 71 degrees. How tall is the antenna to the nearest tenth of a foot? So we have two triangles there. We have the one to the top of the building, which is a 68 degree, and this is 125 feet. And then we have the other one, which this is what we want to find. We want to find that height right there. How tall is the antenna? And so this one is 71 degrees. So what these two have in common is this base, and so we'll call that A. So then the tangent of 68 degrees is 125 over A. The tangent of 71 degrees, well, that's x plus 125 over A. And remember, we want to solve for x. So let's isolate A in this equation here. A will be 125 divided by the tangent of 68. Multiply by A and then divide by tangent 68. Over here, we'll get A times tangent 71 and then divide by tangent 71. So we have x plus 125 divided by tangent 71. So we can set those two equal to each other and we get 125 over tangent 68 equals x plus 125 over tangent 71. Now it's just a proportion, so we take the cross products 125 times tangent 71 equals tangent 68 distributed across is x tangent 68 plus 125 tangent 68. We want to solve for x. So we have x tangent 68 equals 125 tangent 71 minus 125 tangent 68. Dividing both sides by tangent 68, we get 125 tangent 71 divided by tangent 68 minus, when you divide that by tangent 68, we just get 125. All right, so we'll put that in the calculator. 125 tangent 71 divided by tangent 68, and then subtract off 125. And to the nearest tenth of a foot, this is 21.7 feet. This concludes the video for section 2.4 part 2 review.